All right, so switching gears a little bit, right? How many hydrogen atoms are there in each of the following? So what this problem is about is being able to read formulas. So first of all, looking at A, these are all nonmetals. Carbon, hydrogen, oxygen, these are all nonmetals. So it's a molecule. So just reading this formula, how many hydrogen atoms are there in this formula? Well, you've got 5 in the main body of the hydrocarbon there, and then you have this OH group, so there's another H. So when you add those up, you would have 6 hydrogen atoms in that formula. Now looking at B, it's different. This is not strictly a molecule. This is an ionic compound with what's called a polyatomic ion. A polyatomic ion is a molecule with an uneven number of electrons, right? So it has a charge. So in this case, you've got a calcium 2 plus ion and 2 acetates surrounding each other in this crystal. That's what you would visualize. So formula for calcium acetate, you've got the calcium cation, and for every calcium cation, you have 2 acetate anions. Again, so I've tried to draw the picture here that these are molecules with little negative charge, overall negative charge. So, 1, 2, 3, 4, 5, 6 hydrogens for every formula unit of calcium acetate. Say it's formula unit because it's an ionic compound. Same with ammonium phosphate, right? These are polyatomic ions surrounding each other in a crystal lattice. So I've got, reading this in the brackets, I've got the ammonium cation, 3 ammonium cations for every phosphate anion. So that's what this thing looks like, right? When you separate it out, you've got the phosphate molecule with a -3 charge, and for every one of these phosphates, you have 1, 2, 3 ammonium cations, right? And this is how we do formula writing for ionic compounds, right? The amount of cation charge has to equal the amount of anion charge to make a neutral compound. So reading this formula, I've got 3 of these ammonium ions, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen atoms in this formula unit. And that's reading formulas. So molecules with a charge, polyatomic ions, surrounding each other in a crystal. Write the molecular and structural formulas for the compounds represented by the following models. Okay, so we've got drawings here of the molecules that are giving us the geometry. It's just being able to look at this thing and recognizing what it is. So looking at A, I've got 1 bromine attached to this ethyl group. So this is going to be, yes, this would be bromoethane. And the white ones are hydrogens, the black ones are carbons. So I've got 1, 2, 3, 4, 5 hydrogens, 2 carbons, and 1 bromine. So the convention with a hydrocarbon is you put the carbons first in the molecular formula, then the hydrogens, then whatever other atom. So the way you would write this out is C subscript 2 to indicate that you've got 2 carbon atoms in the molecule. H subscript 5, that you've got 5 hydrogens attached, and 1 bromine. So perspective drawing, structural formula, molecular formula. So we've got, what is this? Oh, I'd have to look it up. Dimethylamine. So I'm looking at this. We've got 2 methyl groups attached to that nitrogen in the center there. So when I count up the carbons, I've got 2. I've got 1, 2, 3, 4, 5, 6, 7 hydrogens and 1 nitrogen. So the convention would be put the carbons first, C subscript 2, 7 hydrogens and 1 nitrogen. 1 carbon, 2 hydrogens, 2 chlorines. So again, this is what this thing looks like. This is the structural formula for it, and then the molecular formula. We've got nitrogen, we've got an oxygen. So the way you would lay this out is you'd put the N first, right? So you've got an NH2 and then an OH group attached. So you don't. Later on, we'll get into this more with organic chemistry, but at this point, you'll get the patterns down in terms of what atoms go first in the formula. So these are a little more advanced than some of the others. If I'm doing an ionic compound, the cation goes first, the anion goes second, right? So the metal goes first, the nonmetal goes second. If I'm dealing with a simple molecular compound, the less electronegative element goes first, the more electronegative element goes second. All right, so fill in the gaps in the table. So we did this before, except this time we've got cations and anions, right? Atoms with a charge. So we've got cobalt 59 with a +3 charge. So cobalt is number 27 on the chart. The fact that it's cobalt 59 means that you must have 32 neutrons. Since there's a +3 charge, there's an imbalance between positive charges and negative charges. You got more positives than negative. So 27 protons, you'd have to have 3 less electrons to give you a +3 charge. And that's the way you would fill in the rest of these. Each of the following elements is capable of forming an ion in chemical reactions. By referring to the periodic table, predict the charge of the most stable ion in each. All right, so how many electrons you lose or gain is going to be based on the group you're in the periodic table. There we go. So we've got this idea, laid it out nicely. So there we are. So if you're in group 1A and you're on the staircase side, well, first of all, guys, if you're on the left side of the staircase, you're a metal. You could write a little note. Chemical reactions, the only thing metals ever do is lose electrons. So the question is, how many do they lose? So if we're looking at magnesium, if it's in group 2A, it will lose 2 electrons. If it was potassium in group 1A, it would lose 1. And if you're looking at aluminum, which is below the line here, I mean, I know it's straddling the line, but aluminum's a metal. It will lose, we'll get into more complicated things with aluminum later, but for right now, aluminum will lose 3. So magnesium turns into magnesium 2+, potassium turns into potassium plus, aluminum turns into aluminum 3+. On the other side, if you're interacting with a nonmetal and a metal, the nonmetals are the takers. So looking at sulfur, I'm 1, 2 away from the end, right, to get to argon. So I can gain as many as 2 electrons. So sulfide always has a -2 charge, right? That's the way you name anions, right? Anions. You end them in "ide." So fluorine can take 1 electron to become fluoride, right? It gets to the end of the row. So we look at the group number in terms of how many electrons you're going to lose or gain. So magnesium can lose 2, aluminum will lose 3, potassium can lose 1. So notice the electrons are coming off. The way we symbolize this is we put an arrow for the change. And so it was magnesium, now it's magnesium 2+ plus the 2 electrons you took off. It was aluminum, now it's aluminum 3+ plus the 3 electrons you took off. Going the other way, sulfur is going to take 2 electrons. You're going to add 2 extra electrons to sulfur to make sulfide. So they go in as a reactant. So sulfur plus 2 electrons makes sulfide. Fluorine plus 1 electron makes fluoride. Using the periodic table to guide you, predict the chemical formula and name of the compound formed by the following elements. So A, gallium and fluorine. Well, we look at the periodic table, right? Position on the periodic table is going to tell you, first of all, whether it's a metal or a nonmetal. So gallium is on the left-hand side of the staircase, therefore it's a metal. If it's in group 3A, it'll lose 3 electrons, just like aluminum and indium. So gallium is going to form a +3 cation. It's going to lose 1, 2, 3 electrons. That's what metals do. They lose electrons in chemical reactions. Over to the nonmetal side, right? Fluorine is 1 away from the end of the row, right? So fluorine can take 1 more electron to get to a neon configuration. So fluorine turns into fluoride. So if you're in group 7A, you take 1 electron and become an anion. So gallium 3+, fluoride-, we would need 3 fluorides, every gallium 3+, to get a neutral compound. So that's how you write the formulas, right? You try to write it so it's electrically neutral. The number of negative charges equals the number of positive charges. Now looking at B, lithium and hydrogen. Lithium's easy, right? If it's all the way on the it's all the way on the left-hand side of the chart. The farther we get away from the staircase, the easier it is to take electrons off. So lithium is in group 1A. Therefore, it's going to lose one electron to become lithium plus cation. Now, hydrogen's a weirdo. Hydrogen is in group 1A because it only has one electron, but hydrogen does not act like the ones below it in group 1A. Really, hydrogen belongs over here with the halogens in terms of reacting with metals. So hydrogen is going to be a taker. It needs one more electron to get a helium configuration. So it'll take one electron away from lithium to become hydride. So lithium ion and hydride anion make lithium hydride. And it's the same for the others, right? So we look at the position on the periodic table as to how many electrons you lose or gain, and we make sure that we have the number of positives to negatives so they cancel each other. The most common charge associated with scandium is +3. Indicate the chemical formulas you would expect for compounds formed between scandium and A iodine. Well, iodine is a halogen. It's in group 7A, so it can take one electron to become iodide. I would need 3 iodides to every scandium 3+. So the formula for scandium iodide is SCI subscript 3. Sulfur is 2 away from the end, all right? So it can take as many as 2 electrons. So sulfide has got a -2 charge, scandium's got a +3 charge. So what we're looking for is a common multiple so that the charges cancel. So if I had 2 scandium 3+ and 3 sulfide 2-, the number of negatives to positives would be equal. So I'd have a +6 charge on the one side, a -6 charge on the other side. So the formula for scandium sulfide would be scandium subscript 2, indicating for every two scandiums in the crystal, I'd have 3 sulfides. Nitrogen can take 3 electrons, become nitride. Scandium's got a +3 charge, so it'd be a 1-to-1 ratio in scandium nitride.